What you've just seen. Instead of a row of coils, we've got a row of rods. We're going to feed them with alternating current so that each one can rise and fall. And when we turn the whole thing, we get the impression of something travelling along. But I want you to notice that nothing actually travels along, because each rod only moves up and down. The thing that makes it real is when we put something into one of the troughs of the wave. Then something real travels along, can make it go the other way. If you watch an individual rod, such as this one, you'll see that it's only going up and down. There is no horizontal movement at all. Only the ball is a real thing moving side to side. It's exactly the same with this magnetic river. I can switch it on, and there is nothing above there, nothing moving horizontally, until I put in the aluminium. And it's like putting the ball into the rods. So this is our first step towards a magnetic river. This is a single coil and a plain sheet of aluminium. So it will behave rather like our jumping ring. Switch on and it goes. Try and put it back. It floats. It has a really good try at floating, but it doesn't make it. But if we place it not in the middle of the coil, say it like that, and it doesn't jump straight up. I put it to this side. I put it towards me. And so on. Let us use this spinning cylinder again to see what's going on. Switch on, put the cylinder in the center, nothing happens. Introduce the plate, and it spins. Introduce the plate from the other side, spins the other way. Notice which way. It's trying to throw the plate out. So to try to do this is like trying to balance a pencil on its point. You just won't succeed. But this idea of producing travelling fields, like this, has given us an idea. If we could only produce inward travelling fields without the plate there, then we might have a chance of holding the plate in the middle. So let's try and do that. Instead of a single coil, I'm going to use two coils, one inside the other. This is a coil, and this is a coil, and these three rings are steel rings. They're to help to strengthen the magnetic field. Now, we've found that we can produce this inward travelling field if we make the current in this coil go that way around at the same time as the current in this one is going the other way around. So when we put both coils on together, we can perhaps detect with the copper cylinder a very slight tendency to produce inward travelling fields. That is, the bottom of the cylinder moving towards the centre. That's what we're looking for. Now, magnetic field takes no notice of pieces of wood or cardboard or paper, so I can pass a piece of wood underneath without affecting the floating disc in any way. Now, I want you to imagine that we've been able to take this solid structure, put it under a steamroller, and roll it out flat, really flatten it in this direction. And let's try and imagine what that would look like. Well, here's our aluminium plate, and we'll switch it on. Now, there is our aluminium suspended, but not yet movable. I can push it by hand. It's as if we had a magnetic river without any flow. It's quite stable, but it needs something to push it. So just to demonstrate that, I'm going to put a little air screw on it, and when I switch this on, you get your propulsion. There was a time when we thought we should have to put a linear motor up the centre between the coils to get propulsion as well as lift and guidance. But a few months later, we discovered that all that was necessary was to break up these two coils into a set of smaller coils, and we could get the lift, propulsion and guidance from one and the same set of coils. Now here is one row of coils and the other one at the other side, but this time the coils have been divided up into groups so that we can produce a travelling field as well as give lift and guidance. The thing we're going to propel in the magnetic river is this sheet of aluminium, and we've stuck some tape onto it so that you can see it more easily because it goes rather quickly. So, Barry, if you'll take this, please, and put it on the end and switch on, we'll have a demonstration. Now, I'm going to change over two of the connections to this end of the track so as to make it fire backwards. Now let's see what happens to our aluminium plate. Switch on, please.